Welcome everyone to this walkthrough of chapter 7, section 7.3, confidence intervals for sample size and proportions. We've previously studied in the last two sections sample sizes for means. This time we're studying confidence interval and sample size for proportions, as I said. So a proportion is the percentage of the group that belongs to the category that you're interested in. Now, when we talk about proportions, these symbols should be familiar to you. Uppercase P or capital P is the population proportion. And this P with a circumflex on top of it, we call it P hat because it looks like it's wearing a hat. That's the sample proportion, and that's given by X over N, where X is the number of sample units that possess whatever characteristic you're talking about. So 5 out of 20 dentists say that people have more cavities than they did 10 years ago. So X here would be 5 out of 20, for example. Q hat is the complement, which is 1 minus P hat. We know that from the previous section already. This is our formula for the confidence interval for a proportion. Again, you don't have to memorize it. A couple of things to note here in the formula, however, when we start working on it, is we're working with a Z value. This is always a Z value. Proportions always have Z's. So we're back on a normal distribution for this. The other thing is we're approximating the population proportion. So in our calculation, we use sample numbers. This is P hat, Q hat over N. That can get tricky to remember because of all the P's. But everything here is a sample number except for the middle population proportion. We do tend to test our assumptions. She may ask you to do this. And so we have two assumptions that we follow. The sample must be a random sample. And again, that will be stated in the problem. And N times P hat is greater than or equal to 5, and N times Q hat is greater than or equal to 5. Notice it's not 10, as it was when we were doing the central limit theorem. This is only 5 this time. So note that. Let's take a look at an example, just so you can kind of see how this works. So a US travel data center's SRS, remember this means simple random sample when you see that. So this is talking, when you see SRS, that is an abbreviation for simple random sample. Okay, so that's what that deals with. A US travel data center's SRS of 1,500 adults found that 42% of respondents stated that they favor historical sites for vacation. Find the 95% confidence interval of the true proportion of all adults who favor visiting historical sites for vacations. So what you're going to see her do in the remainder of this chapter and chapter 8 and 9, which you'll see why later, is she's going to state what the parameter is. What is our we call it the parameter of interest. And it basically means what are we trying to do something with? And for parameters, you're going to be looking specifically at when she asks you, what is the parameter, or what is the parameter of interest? The possible answers to that question, okay? Possible answers. There are 4 of them, okay? The mean, the standard deviation, which we haven't gotten to yet. We'll get to that in 7.4. The variance, which is also in 7.4, as you might imagine, because they're related, and the proportion. So when she asks you, what is the parameter? Your possible answers are going to be one of these. Okay, the mean, the standard deviation, the variance, or the proportion. Okay, remember there's 2 ways to get the mean. So here, our proportion is our parameter of interest. She put it in red for you. Find the 95% confidence interval of the true proportion. The answer to this will be in the question, but the reason that it's important is it tells you which formula you're going to use. So here we have 1,500 adults. That's our size of our sample. So N is 1,500. P hat, the sample proportion. So there's 1,500 adults and 42% of them, hence P hat is 42%, 0.42. Q hat we also need, which is the complement, 1 minus P hat, which is 0.58. And then N times P, we note, is greater than 5, okay? N times Q, also greater than 5. So we can then proceed with our method that we would like to be able to use. It actually will work. So we're going to proceed with our with our situation here. Then we go ahead and we calculate it. Okay, she calculated the marginal error first. She didn't show the plugins here, but this is 0.42, 0.58. N is 1,500. Z sub alpha 2 is 1.96 because it's a 95% confidence interval. And then she shows you how it's formed there. I just wanted to show you that example. I'm going to switch screens. And I'm going to share the homework so we can see what that looks like. So in your homework section here, problem 1 is just helping you to find P hat and Q hat. So there's no confidence interval to find. It's just helping you find P hat and Q hat because students have trouble with that. So it's given in a couple of different ways. A, B, and C are kind of the standard way that you normally see it, okay? N is 80, X is 40. So here you'd have, remember our formula from the slide. Our formula says that P hat is equal to X over N. So you're just going to divide x by n to get p hat. So for example, in A, x is 40, n is 80. So if you have, let me bring up the calculator here, you've got, remember here that we have so for 1A, we have x is 40, n is 80, right? So you get, if you take 40 over 80, which you might have been able to do in your head, this is 0.5. So p hat is 40 over 80. So this is equal to, make this a little thicker so we can see it more clearly. So p hat is equal to 40 over 80. And again, the complement of that, because 40 is exactly half of 80, q hat is going to be the complement of p hat. So this is equal to 0.5. And so the complement is always 1 minus p hat. So this is 0.50. And q hat is equal to 1 minus p hat. So this is 1 minus p hat. And so you're going to take 1 minus 0.5, which of course is 0.5. Now, the arithmetic will be a little different, but the process is the same. Q hat is also 0.5 in this case, and that's perfectly fine. They can match each other. Q hat is also 0.5. So A, B, and C followed that pattern. Different numbers, but the same idea, okay? So now if I go back to homework here, I'm going to share the screen. Now I need to look down at the answer key because there's a little omission. Yeah. Here, she didn't specify on D and E which is which. Whether this 0.25 is P hat and whether this is Q hat or whatever. But for the sake of our purposes, it doesn't matter as long as you label one or the other. So for example, on part D, you have D is 25%. So if you go and you say, okay, well, I'm going to do D here, and let me clear this out. So D here is going to be 25% is all it says. So you can assign this to either P hat or Q hat. The idea here is that you understand the relationship between them. So if you start with P hat, being equal to 25%. Change this to a decimal. So this is 0.25. Just move the decimal point 2 places to the left. If you're not sure how to do that, the percent sign here means out of 100. So take your calculator if you're not sure how to convert that. Take your calculator, take 25 without the percent sign and divide it by 100 and you'll get the decimal. This is 0.25. Anyway, that's p hat. Now q hat, as we've said, is 1 minus p hat. So 1 minus 0.25. And that will give you 0.75. So if you assign p hat as 0.25, then q hat will be 0.75 because it will be the complement of p hat. Okay. And that's all that number 1 is asking for. Okay. If you happened to assign q hat as 0.25, then p hat would be 0.75. Just make sure you identify which you intended to be which, but these answers should match. Now let's get into the actual confidence interval formation here. I want to do one problem for you from that. So let me now go back to the homework here. I'm going to do a couple of problems from this worksheet. So let's do number 5. Let's do number 5, and then let's also do number 10. Okay, so I'm going to do number 5 here. The national average for the percentage of high school graduates taking the SAT is 49%. Now what that is that's an approximation of the population proportion, okay? For this, but the state averages vary from a low of 4% to a high of 92%. Okay, they haven't given us anything yet. They just basically told us that the population proportion is about 49%, and the states vary from 4 to 92. So what we're going to do is we're going to use our own data and see if we can come up with an approximation. A random sample of 300 graduating high school seniors was polled across a particular tri-state area, and it was found that 195 had taken the SAT. Okay. Estimate the true proportion of high school graduates in this region who take the SAT. So high school graduates who take the SAT with 95% confidence. Okay. So we need some, in order to be able to do this, we need some data. So I'm going to write it on the screen for you, leave it up, and then I'm going to transfer it to the calculator screen where we can do some work. So let's look at this while we're here, okay? We know that we have N is 300, okay? How do we know this? Because it says a random sample of 300 graduating high school seniors. So N is 300, okay? found that 195 had taken the SAT. So X, they don't give us a percentage here. They tell us that X is 195, okay? And it says that we're looking for 95% confidence here, okay? So my confidence level, CL, is 95%. Now, if you remember from the other calculations that we've done, that means that our confidence coefficient, our Z, should equal 1.96. But I'll show you that again in case you've forgotten how to get it, or in case you're getting it by hand every time. But those should be your numbers, okay? 3 of them came from the problem. 1 of them came from memory because we've done it so long. What we're doing, what these other percentages was for comparison. So we're going to get a confidence interval, and we're going to see how it compares to what they gave us here. Okay, I'm going to leave this on the screen, and it's going to disappear in 5, 4, 3, 2, 1. So now what I'm going to do is I'm going to come back up here, and we're going to form the confidence interval. So I'm going to share the calculator screen here, and I'm going to write some words out. So now, before we can actually do this, I'm going to go ahead and rewrite the annotations that I gave you. So N was 300, X was 195, our confidence level was 95%, and our Z alpha 2 is 1.96. Okay, but there's a couple of things that we need to check first. Okay, so what I'm going to do here before I actually start doing the work is I'm going to say, okay, what is my parameter? My parameter, remember, there's 4 possible answers to that question: mean, variance, standard deviation, or proportion. In this case, it's the population proportion. And I'm going to write the symbol P just to kind of keep that in your head, that capital P is the population proportion. Now, I'm going to test my assumptions because I have some assumptions that I have to test. So I'm going to test them here. Number 1 is I'm going to test N. Actually, let me write this out. So we haven't calculated P hat. We're going to do that right now. But I'm going to go ahead and write this out. So this is N times P hat is greater than or equal to 5. Okay. And so that's actually, I take that back because I need to do something else first. My first assumption technically is, do I have a simple random sample? And I do, because that was stated in the question. So simple random sample, and I'm going to say stated in the question. So we satisfy that, that's a yes. Okay. So that is a yes answer stated in the question. Now for the second assumption, which has two parts. Oops. For the second assumption, oopsie, a little bit off here. Hold on. Okay. For my second assumption, now we go to the NP and NQ. So N times P hat is greater than or equal to 5. So we have N times P hat greater than or equal to 5. And then we're going to do N times Q hat greater than or equal to 5. And she generally wants you to show these assumptions. So I'm doing it here. This is the Q hat, okay? Greater than or equal to 5. Now, you just saw me do P hat and Q hat a while ago. So why don't you pause the video at this point and try to find P hat and Q hat on your own. I'm going to go ahead and do it on the calculator in 5, 4, 3, 2, 1. Okay, so now this is 195 divided by 300. 0.65. Okay, Q hat then is 1 minus P hat. So this is 1 minus 0.65, which is 0.35. So now what I'm going to do is I'm going to say this. Test my assumption here. I'm going to say P hat is 0.65 times my sample size, which is 300, which we should know already because what we got there was 195. So this is, I'll show you in a minute, but this is 195, which is, yes, greater than 5. So yes. Now we have to test the second part. Now let me show you that. This is, oops, this is 0.65 times 300. It's 195. That's how we got this number. That's how I knew that. Now NQ is going to be 300 times, or actually we'll do 0.35 times 300. You could do it in either order, doesn't matter, not wrong. This answer, let's go to the calculator. This answer is 0.35 times 300. So this is 105. And that is also greater than 5. So that means this is a yes. So I can say that the assumptions are satisfied and the method for finding the confidence interval can be used. That's what that means. Okay. If for some reason they weren't satisfied, then I couldn't. Now, one other thing that I have to remind you of, I gave you the Z here because we've done it. The example that we looked at briefly had it also. But I'm going to remind you how to get the Z if you don't remember, or if she gives you a confidence level that you're not familiar with. You come down here. You don't have to draw it, but it makes it easier to see what's going on if you do. So here you've got, oops, here you've got the distribution. And remember, this is a Z distribution, so whoops. Well, humor me, okay? Now we've got two sides. I'll just take advantage of this. This is our confidence interval, right? We're looking for this Z here. Now remember, alpha is 1 minus the confidence level. So an alpha is the area in both tails, which we know from before. So if we say that we have, I'm going to write that, alpha is 1 minus the confidence level. So this is going to be alpha is equal to 1 minus 0.95, which is 0.05. Okay, that's your area in both tails. So what you're going to do is your Z here is going to be equal to inverse norm of 1 minus alpha divided by 2. Okay, that's your, if you remember. So in this case, this piece is going to be 0.025, 0.05 divided by 2. And this is 0.025. So this part is going to be 95 in the middle. This area is 95% in the middle here. But remember, when you enter your inverse norm, it's this tail piece plus this piece that you're entering. So what we're going to do is we're going to go second, distribution, inverse norm, 1 minus, now I'm going to change this because it's not 0.02. This is 0.05. And again, at 0 and 1, because we're on the standard normal, paste it. And there it is, 1.96. Remember, this rounds to 2 places. That's where I'm getting my Z, okay? But when I'm doing a confidence interval for a mean or for a proportion, okay, I'm going to get a Z-score of 2 places. So now we have all of our information. It's right up there. Now I'm going to plug this in. First, I'm going to start with the margin of error, just because that's a little easier to find separately, and then put it in the confidence interval. So the marginal error for this confidence interval is, let me write up the formula again. It's Z alpha over 2. Remember, that is 1.96. We just calculated. Z alpha 2 times the square root of p hat And we know what p hat is. That's why we had to find them. P hat, Q hat. My pen doesn't want it. There we go. P hat, Q hat, Q hat over N. And yes, all of that is under the radical sign. That's my margin of error right there. Okay. So what this looks like when I plug it in is it's going to be 1.96. So this is going to be 1.96 times, and I'll use the star because I'm typing here, square root, SQRT of point. Now remember, p hat was 0.65, right? So we have 0.65 times Q hat, which is 0.35, divided by N. So we're going to divide that by N, which is 300. That's going to give you your margin of error right there. So let's calculate that and see what we get. We have, you get my pointer. Let me clear this so it's less confusing here. This is 1.96 times the square root, second square root. P hat is 0.65 times 0.35 divided by 300. And that is going to equal 0.053974. So this is, usually we round this to 4 places. This is equal to 0.05397. So 39, there's a 7 behind the 9. The 9 technically becomes a 10. We don't have room for a 10. So that 39 is going to go to 40. This is going to be my margin of error to 4 places. Okay. Now, I'm going to, that's my margin of error. That's not my confidence interval. Remember, my confidence interval is, there's a P, right? Population proportion in the middle of it. And we start with our P hat here, plus or minus that margin of error, just like before. So here, this is going to be P hat plus my error term, which we just calculated. That's 0.0540, okay? And my left side is going to be P hat, that looks terrible, but I think you can read that, minus my error term. So this becomes my work then becomes this. It becomes, I know what my p hat is. It's 0.65. So this becomes 0.65 minus that answer that you see on the calculator screen. This is 0.0540 is less than P, which is less than 0.65 plus 0.0540. 0.40. Okay. So now we're just going to do the calculation. We're going to say, okay, we'll say 0.65, 0.65 minus 0.0540. This is 0.596 and 0.65 plus 0.05, 0.704. So this becomes between 0. The 0 is optional here, but it makes it a little bit easier to read sometimes. Less than P, less than 0.704. And then usually we convert to a percentage. So we get 59.6% is less than P is less than 70.4%. And that would be my approximation. Okay. Go ahead and take a screenshot of this if you need to. I'll go ahead and leave it up on the screen. I'm going to have it disappear in 5, 4, 3, 2, 1. Okay. Now 0.596 to 0.704. Let's go back to this. And I'm going to scroll down. And there we go. She left it as decimals. Sometimes she converts these to percentages, but here she didn't do that. She'll let you know in class if you're supposed to, or on the exam if you want. But that is where that came from. Now, the other concept that's in this section is the sample size, the minimum sample size that we need, just like we had for the mean. The formula is different, but the situation is the same. So what I'm going to do is I'm going to go ahead and show you, this is what I needed. Okay, here's the minimum sample size formula. Okay, for an interval estimate of the true population proportion. Okay, so we have n is equal to p hat, q hat. We get those the same way. Sometimes they're given. Our z comes from whatever the confidence level is. Okay, our error will be given in the problem and we square. Okay, remember that n has to be a whole number. So if you get any kind of a decimal, you always round up from it. Okay, so here it says, let's look at our example before we look at number 10. A researcher wishes to be 95% confident. Okay, we need that because we need that for our z. Okay, and we know that z here would be 1.96 because it's always that for a z. So we're going to deal with that. That his estimate of the true proportion of the individuals who travel overseas is within 0.04 of the true proportion. So what's happening is this researcher wants to know how many people travel overseas. And he wants to be 95% confident that the proportion of people that he gets, whatever he gets for that true value, he wants to be 95% confident about it. And he wants his error to be within 0.04 of the true proportion, or 4%. Okay. Now, how large of a sample does he need to take? That's what we want to know. And we need a little piece of information. We need something to base our supposition on. We'll see what happens when we don't have that in a minute. But in a prior study, a sample of 200 people showed that 80 traveled overseas. Now, this is a little bit different because your parameters proportion, your error is 4%. We know that. From a previous study, we know n is 200 and x is 80. And here's my formula. Now, what this does is this establishes for me this previous study, okay? This previous study establishes for me what p hat and q hat are. Okay, so 80 over 200, we know how to do that. That's 40%. If you work it out, we know how to get the complement. That's 60%. Z alpha 2 is always inverse norm of 1 minus alpha. Remember, alpha here is 1 minus the confidence level. So 95, you saw me do that earlier, 1.96. Okay. Then you do the calculation. When you do this calculation, you get 576.24. Now, notice that if you have this number here and you round it to the whole number, this is 576, there's a 2 after it. Normally, you would leave it this way, but this minimum sample size says that if you get any kind of decimal portion, it doesn't matter how small or large it is, you're going to take this whole number up by 1. Why? Because we need 576 and a little bit more to meet our requirement. So it doesn't matter how much of a little bit more, 0.0005 would still be a little more. So we go up by 1 more. Okay, so it doesn't matter what this decimal portion is, take it up 1 number. If you get an exact answer, then use that. But otherwise, take it up. Now, there's one other thing in here. What would happen if I didn't know what the sample size was? What happens if I don't have information from a previous study? Okay, if I don't have information from a previous study, then I use 0.5 for my proportions. But if I do have information available, then I actually, I told you I was going to do number 10, but I think I'm going to do number 9 only because it has that in there. Okay. So for number 9 here, let me put this on the screen. Let me make sure that I'm sharing it, first of all. Let me put this on the screen. It is believed. Okay, so this is what we believe now. Okay, so this is my estimate. It is believed that 25% of US homes have a direct satellite television receiver. How large a sample, and this is how I know that I'm not doing a confidence interval, okay? Because it doesn't say find a confidence interval. It says how large a sample. This is sample size. What is the sample size necessary to estimate the true proportion? Well, we have one estimate, right? How large a sample, how large a sample? See that? Anytime you see that, these are sample size calculations, but it is believed that 25% of US homes have a direct television receiver. How large a sample is necessary to estimate the true proportion of homes that do what? That do have a direct television receiver with 95% confidence and within 3 percentage points. This within is my error. When you see within a certain amount, within the thing that follows within, the thing that comes after it is my error term. Okay. Now here in the first part, number 9 is going to have 2 answers because there's 2 questions. There's a question here and there's a question at the end here. There's going to be 2 answers to number 9. Okay. So in the first part of number 9, what we're dealing with is this. So I'm going to call this first part 9, first part. What do we have? We have n. We don't know. We don't know what n is. We don't know what n is, but we do know that we want our confidence level is 95%. Now we need the confidence level, not so we can form the confidence interval, but so that we can figure out what our z is. Okay, we need that to know that, but we're not forming a confidence interval here. Okay, so confidence level is 95, which leads us to the fact that z is 1.96. As I showed you in the last example I've shown you before, we come to that same conclusion. Z is 1.96. Now it says within 3 percentage points. So my error here, now, sometimes people get this confused too, is you'll see them put 3 there for E. This is 3 percentage points. So your error here is 0.03. Make sure you use the decimal. If it didn't have percentage points, it just said 3 cookies or 3 units or 3 receivers, okay, then you could do something with that. All right. Like if you look back at some of the means, it'll say to estimate the true number of cookies within 3 cookies or something. But if it says percentage points, use the decimal. Okay. So we're going to go ahead and calculate that. I'm going to leave this up on the screen for a minute so you can record that, and then I'm going to put it in the calculator and we're going to see what we get. All right, so here's my data, right? So here's what it looks like. I'm going to go ahead and let it go in 3, 2, 1. So now I'm going to come back to this formula here. This is my formula. P hat, Q hat, Z alpha 2 over E squared. So in our case, this is going to be not these numbers. It's going to be, if you remember for our example, we're going to have 0.25, and I'll put this back on the calculator screen in a minute. I just want you to have the benefit of the formula. P hat is 0.25 because remember we had 25% that use a satellite receiver. Q hat is 75%, 1 minus 0.25. Our Z is 1.96, because again, we have the confidence interval, and our error is 3 percentage points. And we're going to square that. So we're going to say, we're going to square that. So for our example that we're doing here, this I put, oops, that's wrong. Let me erase this because I put 77 instead of 75. This is 0.25 times 0.75. This is 1.96 divided by 0.03, and I'm going to square it. So now I'm going to leave this here. This is what your plugin should look like. I'm going to put this on the calculator screen in a moment. In 3, 2, 1. So now come over here and we're going to put this in the calculator. So we have 0.25 times 0.75. We're going to put 1.96 divided by 0.03. And we're going to close that parenthesis and square just what's in the parenthesis. That gives us 800.3333, whatever. Now, again, if I'm rounding 800 to the nearest whole number, this is going to be 800, but any fractional portion I need, I'm going to round this up. So I'm going to report my answer as 801 for the first part, assuming that I had a 25% proportion available. Now, going to go back to the homework here. And I'm going to scroll down. This is problem 9, 801. Now, for the second part of this, okay, how large a sample is necessary if nothing is known about the proportion? Now, the second part of this, if I don't know anything about the proportion, then when nothing is known about the proportion, always use the most conservative estimate you can and still get away with it. You always use, excuse me, you always use 0.5. That's the rule of thumb. So we're going to use 0.5 for both of them. Okay, that's just a convention. So in this case, everything stays the same as it did in the first part. Remember here, I should probably put this on the screen for you so we can remember in case you're taking notes as you go. Remember, we used p hat here was, in the first part, was 0.25. And q hat then was 0.75. Okay, I should have written that, but all you're going to do in the second part, nothing changes except p hat and q hat. Okay, so this is going to be, instead of 0.25 and 0.75 this time, we're going to get 0.5 for each one. And we're going to get a different number, obviously. So I'm going to go ahead and leave this up for you to do the second part of the calculation. Everything else is the same. Okay, so what we're going to do now, this is going to disappear in 3, 2, 1. So now I'm going to come over here to the calculator. Make sure that I'm sharing it. Okay, yes. And all I'm going to do is I'm going to come down, or come up, I should say, grab this expression that I used, and all I'm going to do is replace, oops. Well, first I'm going to delete this 801 out of the way, but I'm going to put 50 in each part of this. Okay, so 0.50 times 0.50 times 1.96 divided by the square root of 0.03 squared, and that's equal to 1067.1111. Again, you always round up, so it's going to be 1068 as my final answer. Now, if I go back to the screen here, then I can verify that, in fact, there it is. Number 9 is 1068. Now, I promised you that I would do number 10, so let's set up number 10, and then we'll do it with the calculator, okay? Number 10 has a different Z, so it's not a Z that she didn't give you, but it may cause you some issues. Nearly one half of Americans aged 25 to 29 are unmarried. How large a sample is necessary to estimate the true proportion of unmarried Americans in this group within 2.5 percentage points with 90% confidence? So, number 10, we start number 10. We start number 10 with the idea that our parameter is population proportion P, right? Population proportion P, right? And then you say, well, okay, what do I know? Nearly one half, it says. So I'm going to let's see. I'm going to draw here. I'm going to draw. Okay, so my P hat here is nearly one half. So my P hat is going to be one half, which you can use the fraction and divide it, but you want the decimal portion. So this is 0.5. Q hat, as we've seen, is the complement. So I'm just going to write Q hat is equal to, okay, I think I've lost this. So I'm not sure where I lost you, but we're doing number 10. Parameter is the population proportion P. P hat is 0.5, Q is 0.5. And now I'm going to say that I don't have my N. I don't know what my n is because I'm looking for it. How large a sample? I don't have it. My z, though, is going to be related to 90%. So if you're not sure, here's your drawing. You do not have to draw. You can use the formula if you want, but I prefer to show you. So this is 90% here. That means we're going to have 10% total in the tails, okay? Because my alpha here, my alpha is 1 minus the confidence level, which we know is 90%. So my alpha is equal to 1 minus 0.90, which is 0.10. And therefore my z is equal to inverse norm of 1 minus 0.10 divided by 2. Now, this is where if some of you are using the tables or the textbook or sometimes an online calculator, you may have a slightly different answer for 90% than the book does. We'll come back to that in a minute. My error here, it says within 2.5%. So what I'm going to do, error here is, this is 2.5%. So there's a couple of things I'm going to show you because there's a couple places that potentially mess people up. Percent means divide by 100. So take a minute to write this down, okay? And I'm going to have it disappear for you. Let me first, I think I lost my screen share. So let me put it on the screen for you. And I'll leave it up for some time so you can write number 10. I haven't done the sample size calculation yet, but it's going to disappear in 5, 4, 3, 2, 1. Now, what I'm going to do is come over here and show you a couple of things on the calculator. One of them is this 2.5%. Now, remember, if this is a percent, okay, even though it has a decimal in it, it's not a decimal yet. So 2.5% means you divide this by 100. So your error is going to be 0.025. Don't forget that, okay? Error here is 0.025. So we're looking for n. This is number 10, okay? We're looking for n. We don't have it. Our confidence level is 90%. Our alpha is 0.10. Now, the other thing, and our error, as I just showed you, the error is 0.025. Okay. Now, the other part of this is my z. My z here is inverse norm 1 minus alpha, which is 0.10, divided by 2. So here I'm going to go ahead and use my pointer here. Second distribution, inverse norm, number 3, right here. This is going to be 0.10 instead of 0.5. 0.05, 0.10 divided by 2. Now, why did I show you this? On the calculator, you would report this as 1.64, okay? If you're using the calculator, it's 1.64. The book and almost every other source online uses 1.65. And that's because if you're using the tables in the book, there are two values that are equally close to each other, and we take the higher one. What the calculator did was average it. So she will accept either value from you, but she usually uses, I'm going to go ahead and use my Z as 1.64 or 1.65, and I'll show you the difference because they are slightly different, okay? But she tends to use 1.65. So she does have the 1.64 answer, but this is what happens. And it only happens with 90 when you're doing the Z's. So let's do your N here. So we have, remember P hat, and we had, let's go back. So we have P hat was 0.5 and Q hat was 0.5. So now this is going to be P hat, which is 0.5. Oh, if you want to put the 0, you can. It's not necessary. Times 0.5. Then you're going to P hat times Q hat. This is your Z. We're going to use, I'll do both of them so you can see it. Here's 1.64 divided by my error, which is 0.025 for reasons that I explained to you. This is squared. Okay. There's my, now if it's 1.64, this comes out to 1076. If I come back and make this 100th larger, then this goes to 1089. Okay, so they are slightly different. She is aware that it does this. This is not a mistake in the key. It's an inconsistency between the textbook and the calculator. It's not a mistake. So this, you could report 1076 again, as long as you show me which Z you used. Now, if you show me the formula that I just gave you, you're going to show this first answer, but I think her answer is actually the second one. Let's go back and look at it. So here, this is, let's scroll down. Yeah, she has the second one because she used Z is equal to 1.65 for that, okay? So just be aware that on 90%, typically we use 1.65. That's what the textbook will use because they're using the chart values, okay? I hope this video has been helpful to you, and I'll see you in my next video. Thank you very much.